Welcome to the course Formal Language and Automata Theory. In this lecture, we are going to solve some example problems of Greibach normal form. In our previous lecture, we discussed the procedure for reducing a context-free grammar to Greibach normal form. Then an example problem is solved. So today also we will solve some more problems. So as per the procedure, to convert a given context-free grammar to Greibach normal form, first step 1, convert a CFG to Chansky normal form. First step. Check out whether the given grammar is in Chomsky normal form or not. So given CFG, S derives SS is in CNF because right hand side two variables are there. But S derives 0S1 or 01 is not in CNF. So reduce to CNF. So before reducing to CNF, you can check out any null productions, unit productions, or useless symbols. So given CFG contains only one variable, that is S. Starting variable also same. So S derives the string. So terminal string is deriving. Then S is reachable to S itself. Therefore, no useless symbols. Then no unit productions also. Then no null productions also. Given CFG doesn't contain any null productions, then useless symbols, and unit productions. Directly you can proceed to step 2 of CNF procedure. So S derives 0S1, then S derives 01. Separately take these two productions. So here it is in the form of CNF procedure step 4. That means in between, if we have a terminal between the variables, so introduce variables for terminals. So now if we can introduce like this, suppose S derives D suffix 0 S D suffix 1, where D suffix 0 derives terminal 0, D suffix 1 derives terminal 1. Now we can apply step 3 of the modified S productions. Now S derives D0 S D1 by CNF step 3. We have to split by introducing new variable. D0 keep as it is. The remaining you can assume it as D2, where D2 derives S D1. Now you can see these are all in CNF. Similarly, S derives. For 0, we already introduced a variable D0. For 1 also, we introduced a variable D1. You can substitute directly. S derives D suffix 0, D suffix 1. So, E is in CNF. So now, This is in CNF. Then these two are in CNF. Then these are also in CNF. Then already S is in CNF. Now you can write on the final CFG in CNF. Final CFG is in CNF. Is shown below. Now write in all productions in order. First S derives SS. Then you can combine all S productions. Then the new productions of S are this one D0 D2, D0 D2, this one. Then other S productions are D0 D1, D0 D1. Then any others? So this is one S production. Then this is 2. Then this is 3. Total 3 S productions are there. Now the new variables are introduced. You can write down the new variables productions also. So here D0 is one variable. D0 derives terminal 0. Then D1 derives also terminal 1. Then other new one is D2. Now D2 derives. Here you can see D2 derives yes D1. Only one production is there. So which is in CNF. So in the Greibach normal form, step 1. So reduce the grammar into CNF. Then what you have to do in step 1 itself, rename variables as A1, A2 and so on, AN, where A1 belongs to S, starting variable. Now in the resultant CNF grammar, the variables are S, then D0, D1, D2. Total 4 variables are there. Therefore, rename S, D0, D1 and D2 as, now S becomes A1, D0 becomes A2, D1 becomes A3 and D2 becomes A4 respectively. Then all productions will be modified in the form of step 2, that is AI derives AJ gamma format. Now write on the resultant productions. First S derives. S means now A1 derives. Right hand side 2 S are there. So again S means A1 only. A1, A1, or next D0 becomes A2. Then D2 becomes A4. Then again D0 becomes A2. D1 becomes A3. These are all S productions. Then D0 derives 0. Now D0 means A2 derives 0. Then D1 derives 1. Here D1 means A3 derives 1. Then D2 derives. Here D2 means A4. A4 derives S D1. What is S here? A1. D1 means A3. Now see, all the productions are of the form AI derives AJ gamma format. Now you can proceed to step 3 by taking the productions which are of the form step 3 AK derives AJ gamma. such that here you can see J less than K. So K is higher value. So take any production of this form, then substitute AJ productions in the right hand side of AK. Then this may be reduced to some other form, that is AK derives AL gamma, where L equal to K. Then you can apply lemma 2, that is eliminating left recursion, wherever applicable. Otherwise, if any productions are already in GNF, those values we can substitute here. Now let us check once first A1 productions. A1 derives A1 A1 or A2 A4 or A2 A3. This is not in GNF, whereas A2 derives is in GNF. A3 derives 1 is in GNF. That is single terminal also allowed. But A1, A4 are not in Greibach normal form. So we have to reduce these two productions into GNF. If you can consider A1 derives A1, A1, here you can see this is already in the lemma 2 format, that is the left recursion format. Then by applying lemma 2 for A1, once you can reduce A1 to GNF, then A4 derives A1. Directly you can substitute A1 productions in A4. Then A4 also reduce it to GNF. So therefore, consider A1 derives A1 A1 or A2 A4 or A2 A3 is in the form of lemma 2. Now by lemma 2, see, you can again rewrite here. You can nomenclature with lemma 2. Now this is A, again A, after A alpha. Now this is beta 1, beta 2. So only we have one alpha value. Why? Because the left hand side variable A1, right hand side leftmost variable A1, matching in only one production. But here A2 is not matching with A1. Therefore, the first set of productions, A1 derives, first what you have to take, beta I. Beta I means beta 1, beta 2. That is A2, A4 or A2, A3. Now see, this is beta 1. Now this is beta 2. Now the second production of A1, that is beta I x by introducing a variable x. Now A2, A4, now introduce x, then A2, A3, again you can concatenate with x. So now this is beta 1x, then beta 2x. Now the second set of productions by rule 2 of eliminating left recursion. Here x is new. X derives alpha I. Here only one value we have, A1. This is alpha. Next one is x derives alpha x. Now you can see the resultant productions. A1 derives A2 A4 or A2 A3. So not in left recursion. A1 derives A2 A4 or A2 A3. Here you can see this is also not in left recursion format. X derives A1, then X derives A1X. Now you can check out the resultant productions of A1 and X are in GNF or not. This you can verify. If so, you can substitute the other values. Now you can see the new A1 productions obtained in step 1, that is in the rule 1 of left recursion elimination. Here it contains A2, but check out A2 is in GNF or not. A2 directly in GNF, that is 0 is there. You can substitute this value in set 1, set 2. In set 1 of A2, in the right hand side, leftmost A2. So let us say this is equation 1. Now equation 2. Then directly A1 becomes GNF. So substitute A2 productions. So A2 production means which one? Which is in already in GNF. A2 derives 0. A2 derives 0. That is A2 derives 0 in equations. Which equations you can substitute? That is a Roman letter 1 and 2. Equations 1 and 2. Therefore, 1 implies, now you can write on the A1 derives here A2, A4, then A2, A3. So here you will get A2, A4 and A2, A3. Now what is the A2 value? We are substituting terminal 0. Now 0, 0. Now you can see A1 derives 0, A4, terminal followed by variable. Then 0, A3, terminal followed by A3. So he is in GNF. Then another A1 production second set. That is again here A4 with variable X. Then A3 with X. Now here A2 you can substitute again. Here 0, 0. Now you can see terminal variables. Terminal variables. Even single variable or more than one variable. So is in GNF. Now you can see this A1 productions are in our required GNF. Now what you have to do? Further X productions. X derives A1, then X derives A1X. Now in X production, right hand side leftmost A1, you can substitute this new A1 production. Then X is also in GNF. Now this you can make it as Roman letter 3, 4 equation. So now substitute. So wherever substitution we are doing using substitution lemma. Substitute A1 productions. Which A1 productions? Which are in GNF. The previous one, which are in GNF. In X productions. That means from the equations 3 and 4, which are in 3 and 4, where you have to substitute in the right hand side of X, leftmost A1 only. Therefore, Roman letter equation 3 becomes, so X derives A1. So A1 means total 1, 2, 3, 4 productions are there. All 4 you can substitute here. Now 0, A4, this is the first one. 0, A3, this is the second one. Then second A1 productions, 0, A4X, then 0, A3, X. The total 1, 2, 3, 4. 4 A1 productions are substituted in first X productions. then Roman letter 4. That is second X production derives. Same as above one, but concatenated with X at the end. So you can take down the previous one as it is, 0, A4. Now concatenate with X each and every one. 0, A3, X, then 0, A4, X, then concatenate with another X, then 0, A3, X, concatenate with other X. Now these are all the new X production. See, terminal variable, terminal variable, terminal variables, terminal variables, then terminal variables, terminal variables, terminal variables, terminal variables. So he is in Greibach normal form. Now all X productions are reduced to GNF. Now all A1 productions also reduced to GNF. Then go back to step 2, check out which are not in GNF. Now A1 is reduced. A2, A3 already in GNF. Then A4 is not in GNF. So A4 derives A1, A3. Now A1 we modified into GNF. Now substitute the GNF productions of A1 in A4 productions in the leftmost A1 of right hand side. So now A4 derives A1, A3. A4 derives A1, A3 is not in GNF. So now the new A1 productions which are in GNF, total 4 productions are there. Those you can substitute here. Substitute A1 productions in GNF. In A4 productions, that is right hand side leftmost A1, you can substitute all the A1 productions. Therefore A4 derives. So A1 we have 4 productions. The first A1 production, then second A1 production, then third A1 production, then fourth A1 production. Then at the end A3 remains same. Now first A1 production value is 0, A4. 0, A4. The second one is 0, A3. So the A3 remains same in each and every production, ended with A3, that is already there. Then third A1 production 0, A4X. 0, A4X. Then fourth A1 production 0, A3X. In underline, whatever we underline, those are all A1 productions, total 4 productions. Now we can see this is the final A4 productions. Check out, is it in GNF or not? Terminal 0, then A4, A3 are variables. Terminal 0, A3, A3 are the variables. Terminal 0, then A4, X, A3 are variables. Terminal 0, A3, X, A3 are variables. So this is in the required form. E is in Greibach normal form. Now all the resultant productions which are in GNF, you can write down at one place. This is the A4 resultant productions. Now these are all X productions which are in GNF. Then these are all A1 productions which are in GNF. Then A2, A3 already in GNF. Now all at one place you can write down. That is the final GNF grammar. Therefore, final CFG is in GNF. Is shown below. Now write down all productions one by one in order, which are in GNF, which are rounded. First A1 derives. The A1 GNF productions are this 4. All you can combine. starting with same variable, you can combine 0A4, then 0A3. Terminal 0A4, then 0A3. Then second set of A1 productions by adding variable x, 0A4x, 0A3x. Now A1 is over. Now A2, which is already in GNF. So what is A2 value? A2 derives terminal 0. Then A3 derives terminal 1. So A2 derives 0. Then A3 derives 1. Then A4. A4 derives which are in required form. This recent A4 productions. 0 A4 A3, 0 A4 A3, or then 0 A3 A3, 0 A3 A3, or then 0 A4 X A3, 0 A4 X A3, or then 0 A3 X A3, 0 A3 X A3. So these are all in GNF. Then other missing productions, X productions also you can write down. Now X derives. X also contains two sets, 1, 2, 3, 4, 5, 6, 7, 8. All you can write down. X derives 0 A4 or 0 A3 or 0 A4X or 0 A3X or now other set of X productions. Same as above by adding X at the right end, 0 A4X, 0 A3X, and so on. Now here you will get 0 A4X, 0 A3X, or 0 A4X, then another X is combined. Then 0 A3X, then another variable X is concatenated. So 1, 2, 3, 4, 1, 2, 3, 4. Now you can see this is the final grammar which is in Greibach normal form. So A1 is in GNF, A2 is in GNF, A3 is in GNF, A4 is in GNF, then X is also in GNF. So like that, any given problem, we can reduce into Greibach normal form. Now, you can practice other problems in the similar fashion. So here one more example is taken. You can do this problem in the similar fashion. Here you can see, check out whether the grammar is in GNF or not. Given CFG, S derives AB, then A derives BS or B, then B derives SA or A. Here you can see S derives AB, two variables length. Then A derives BS, two variables length or a single terminal B. B derives SA, two variables length or a single terminal A. E is in CNF. So the given grammar directly is in Chomsky normal form. So as for step 1 of GNF, then what you have to do? Rename. Rename variables S, A, B as A1, A2 and A3 respectively. Now the grammar is modified according to step 2. Now the modified grammar you can write down. Now S becomes A1. A1 derives, A becomes A2, then B becomes A3. These are all the new S productions. Now A becomes A2, derives B becomes A3, S becomes A1, or terminal B remains same. Now B becomes A3, derives S becomes A1, then A becomes A2, then terminal A. Now check out which are the productions of step 2 or in GNF. So here A2 derives B in GNF, single terminal. Here A3 derives A in GNF. So before applying either lemma 1 or lemma 2, the right hand side leftmost variable that should be reduced to GNF. If it is already in GNF, no problem. You can substitute that respective value. For example, if you can see A2, first A1 derives A2, A3. But here this A2 checkout is not in GNF, only one value. One is in GNF. Then A3 derives A1. First we have to reduce this A1 into GNF. Then automatically A3 will be reduced to GNF. Now first, which one you need to consider? For example, A3 derives A1, A2. If you can substitute A1 productions here, it is in the form of step 3. AK derives AJ gamma, where J less than K. So if you can substitute A1 productions, what will happen here? A1 contains A2, A3, A2, A3, but it won't be in the form of left recursive form. Then A1, A2 not possible to apply step 3. Why? Because not in the form of AK derives AJ gamma with J less than K format. Now what is the alternative way we have to follow? See, we have A2 derives a single production terminal. So this terminal B is in GNF already. Then in A2, A3, if you can substitute terminal A, now this will also reduce it to GNF. So now let us see. Already in GNF we have A3 derives A, substitute in A2 productions. That means in A2, A3 value. So therefore now A2 derives. Now you are substituting A3 value. So A1 RB, which are in GNF, that only you can substitute. So now what is the A3 value you are substituting here? So terminal A. Now you can see A2 derives terminal variable or a terminal. So this is in GNF now. In GNF. Now where you can substitute this A2 value? In the A1 production, right hand side leftmost A2. If we can substitute this A2 production. So now A1 also reduce it to GNF. So now substitute A2 productions which are in GNF in A1 productions, that is right hand side leftmost A2. Now A1 becomes, here A1 is A2, A3. A1 derives A2, A3. Now this A2 you can substitute the above two productions. Now this will becomes A1 derives. The first one followed by A3, then the second A2 production followed by A3. The first one is A1, then the second one is B. Now you can see terminal followed by variables, terminal followed by variable. So now this A1 is in GNF now. Now A1, A2 are reduced to GNF. Then coming to A3. So A3 right hand side leftmost A1 is there. Here you can substitute the new A1 productions which are reduced to GNF just now. So now A3 derives A1, A2 or terminal A. A1, A2 or terminal A. Substitute A1 productions which are in GNF. Recently we obtained. In A3 productions, that means right hand side of leftmost A1. That means in this place A1. Now A3 becomes, now first A1 contains two productions. So first A1 production A2, then second A1 production A2, then the terminal production remains same A. Now first one is A variable A1 variable A3. The second A1 production terminal B variable A3. Now you can see terminal followed by variables. Any number of variables, no problem. But must not should start with the terminal. That is the condition of GNF. Now terminal B variable A3 variable A2 or a single terminal. So in GNF. Now you can see all the productions are reduced to GNF. So here also in this problem we didn't applied lemma 2. That means that requirement not came here. So whenever it is required, whenever reduction is not possible, at that time, whenever left recursion is possible, at that time only you can apply lemma 2. Here always we applied lemma 1 only, substitution rule. Now all productions which are in GNF, the final grammar you can write down. Therefore, final CFG is in GNF is shown below. All productions in order you can write down. First A1 productions which are in GNF, that is A1, A3, terminal A variable A1 variable A3, then or terminal B variable A3, terminal B variable A3. Then A2 productions which are in GNF, the resultant A2 productions, terminal A variable A1. So A1 or B. A2 derives A1 or B. Only two productions are there. Then A3 productions, the resultant A3 productions are which are in GNF. A3 derives terminal A, A1, A3, A2, and terminal B remaining variables A3, A2, then or a single terminal. Now you can see all A1, A2, A3 productions. So this grammar which is in GNF, Greibach normal form. So like that any given problem, the same process you can apply.